All right, greetings YouTube, beautiful mind here. We have this question that comes in from calculus. So this is from homework assignment. This is question number 9. It says find the horizontal and vertical asymptotes of the curve. We have y equals 2x squared plus 3 over 3x squared plus 14x minus 5. Okay. So horizontal and vertical asymptotes. So an asymptote is like for instance, a vertical asymptote is this like a dash vertical line that the graph gets really like infinitesimally close to it, but the vertical asymptotes, we don't actually touch it, right? So we get really close. When you look at the graph, it's going to look like it touches the line, but if you zoom in, there's always going to be space between our graph and that vertical line, right? So vertical asymptotes, we get infinitesimally close to it, but we never touch it. Horizontal asymptotes are like, okay, how does the function behave as x goes to either positive infinity or negative infinity? If you can like grasp the concept of how it's behaving as we go towards positive infinity, usually negative infinity is a similar concept. And I'll try to do this based on like how we do it in calculus, especially when it comes to the horizontal asymptotes. There is an alternate version. It's like a 3-pronged test on how we do this in college algebra. So sometimes you might see that as well. But I'll try to stick to the calculus technique here. So let's start off with the vertical asymptote, right? And so the vertical asymptotes are going to occur when at those values of x that make the denominator 0 and the numerator is some number other than 0. If you ever get 0 divided by 0, like if some value of x gives you 0 over 0, that's going to be a hole or a gap in the graph, right? But the vertical asymptotes occur when we have some number other than 0 divided by 0, okay? So here, what we want to do is we want to find those values of x that makes the denominator 0. So again, for calculus, a precursor, something that they pretty much expect you to already have some level of proficiency with, is this concept called factoring. Again, that does come from intermediate algebra. I have material that's dedicated to kind of walking you through factoring. It's a whole chapter. But yeah, with calculus, they do expect you to already know factoring. And that factoring is one of those concepts that tends to give students a hard time. So with this one, what we want to do is set it equal to 0, and we want to factor, right? So now, first question, if we're looking at the denominator, we're trying to find out what values of x make the denominator 0. First question we ask ourselves is there a greatest common factor, a GCF? So there's no greatest common factor with those three terms, with the 3, the 14, and the 5. So there's no greatest common factor. So then the next question we ask ourselves is how many terms are we trying to factor in? Are there 2 terms? All right. Then there's a set of techniques there. Are there 3 terms? Now, I pretty much do one technique when it comes to 3 terms. And that's pretty much what we'll do here. It's a little bit involved, but once you get it, I would say at least 80% or 90% of the time, if it's a trinomial where it has 3 terms, it works at least 80% of the time, if not more. And then the third question you ask yourself, are there 4 or more terms? If there are 4 or more terms, we would do a technique called factor by grouping. But this one is 3 terms. So when I'm trying to factor in a trinomial, I use a technique called the AC method of factoring, right? So like in general, this would take on the form like a ax squared plus bx plus c, where our a is 3 and our c is -5. So first thing I want to do is say my a times my c. So I'm going to say my 3 times my -5. That's going to give me -15, right? So off to the side, I'm going to look at -15. So now the goal that I'm trying to do, I'm looking for 2 numbers that multiply to give me -15 and add to give me 14, right? Now I think we got, this is a whole technique that this isn't something that you would just figure out. Like you would have to already have this kind of ready to go, factoring, right? So if this is foreign, you definitely want to like just do a little bit of digging on some factoring scenarios. And again, I do have a chapter devoted to like kind of walk you through most of the scenarios for factoring. So if anybody needs it, just let me know and we'll pull it up. So if I say my A times my C, I get my negative 15. So now what I'm going to do is I'm going to go through all the factors of negative 15, and I'm going to stop at the line that adds up to 14, right? So now 15 was what? 3 times 5, right? So I don't think we have that many to test. Now the factors are things that multiply or divide, right? So I'm going to go through all the factors of negative 15. First we got 1 and 15, and I think we got it off the rip. Because negative 1 times 15 is negative 15. And then negative 1 plus 15 is 14, right? So these are the two numbers that we were looking for. So that's the first part of the AC method. I said my A times my C. I was looking for two numbers that multiply to give me my A times my C and add to give me B. And these are those two numbers. So now the next step with the AC method, I'm going to invoke what's called the box method, right? I had a different one, but I think the box method is a little bit easier to process. So now that we got these two numbers, the way the box method goes is something like this. So let me see. I'll do this in purple. Right? In the upper left-hand corner goes my leading term, which is that 3x squared. In the bottom right-hand corner goes my constant, which is negative 5. And then on the off diagonal, what we're doing is we're taking that middle term, which is that 14x, and we're using those two numbers. So instead of writing 14x, I'm breaking it down into negative x plus 15x, right? So those two numbers that we found, we put them on the off diagonal in the following fashion. We could say like negative x and plus, or we don't need the plus, but 15x here, right? So with the box method, once we have that set up like that, now we just kind of do something like this. So if we focus on the top, what's the greatest common factor with those on top? Well, the greatest common factor with 3 and 15 is going to be the 3. So we can factor out a 3. And they both have at least 1x. So the greatest common factor between those two terms is 3x. What's the greatest common factor here? What do these have in common? Well, they both have what? Negative 1. Okay. So again, factoring is one of those things that they expect you to know for calculus. It's not trivial. It's not easy. It's doable, but you just need some practice and exposure. Yeah. Okay. So we did the 2 on the top. We did the 2 on the bottom. Now we need to do the 2 on the left. All right. What do these have in common? I think they only have x in common. All right. And then finally, the 2 on the right. What's the greatest common factor? We can factor out a 5 from both of those. Okay. So then ultimately what we're saying, that denominator, let me copy and paste. So what we're saying is that we can factor that denominator into the following. Let me go like this. So I think before we kind of explored some examples where we did foiling, first, outer, inner, last. We started with a binomial times another binomial. We foiled and we got an answer. Combined like terms, we get an answer. Now what we're doing is starting with the answer and working backwards. That's what factoring is. Factoring is starting with those answers and working backwards, right? And so it's this whole thing. So we got what? X plus 5. And we got 3x minus 1. Okay. So that denominator that we started with, again, I basically use this technique called the AC method of factoring. Let's recap real quick. AC method of factoring. I said my A times my C to get me the negative 15. And then I basically listed all the factors. We got lucky because the first set of factors were the two numbers that we were looking for. We were looking for two numbers that multiplied to give us the negative 15 and added to give me the negative 14. And it just happened to be the first set. If this didn't work, I was going to try 2, but I don't think there's a 2. I could have done negative 3 and 5. All right, and just going through all the factors. So then once we had those two numbers, then we went into this technique called the box method. All right, it's kind of make this little purple fish, downward diagonal fish thing. The upper left-hand corner was the leading term. The bottom right-hand corner was the constant. And then the off diagonal were the two numbers that we found in this fashion. All right, the -1 and the 15. Then we said, well, the greatest common factor here was this guy. The greatest common factor here was this guy. The greatest common factor here was X. They both had at least one X. And then the greatest common factor here was 5. So then once we finished that denominator, we were able to get it like this. And again, we get this answer, we would check by foiling. Okay? If we foil it out, we should get the above line. That numerator, no, I don't think this helped us, but it does, yeah. That numerator, nothing looks like we can cancel or anything. So something like this, okay. So now that we have the denominator factored, if we want the vertical asymptotes, that's going to be, now we want to find the values of x and make the denominator 0. So we set each factor to 0 and solve, right? So if we set this x plus 5, if we set it equal to 0, subtract 5 on both sides, x equals -5, right? That's one of them. We also need to make sure that when x is -5, it doesn't also give us this 0 in the numerator. Same thing for the other factor. We have this 3x minus 1. We set it equal to 0. We add 1 to both sides of the equal sign. This adds to 0. Equal sign comes down. Divide both sides by 3. So that x equals a third. Okay. So we're saying that when x is 5, or when x is -5, or when x is a third, that's where a vertical asymptote should occur. -5 and a third. And again, we should plug them into the numerator to make sure they don't also give us a 0 there. Let me see. That's going to be a 25. Okay, so the 5 is clear. And I think the third is clear. I think those are both good. Okay. So when we plug these values in, we get like some number divided by 0. So these are the equations of our vertical asymptote. So if we were to look at this graph, when x is -5, we would have a vertical asymptote there. When x is a third, we should have a vertical asymptote there. Okay. So that's the vertical asymptotes. Then for the horizontal. So the horizontal asymptotes are concerned with the limit as x goes off either to the far right or the far left, as x goes to either infinity or -infinity. Once you kind of show it for infinity, it's a similar explanation for -infinity. So let's do this. Let me paste. And I'm going to get rid of this. All right, so for the horizontal, I'll just abbreviate it as the horizontal asymptote. And this, let me label this as well. This was our vertical asymptote. I'm gonna move this over, shrink it down a little bit. I don't know why I got translucent, but okay. All right. So for the horizontal asymptote, what we're considering is the limit as x. We're just going to focus on as x goes off to the far right, as x goes to positive infinity. So I know we just kind of worked several examples similar to this. Okay, I'm going to kind of explain it. Let me think. I'm more of a fan of factoring. I'm just gonna do that. I'm gonna factor out x squared, right? I think we're gonna factor out the x squared from everything. So then we're gonna get something like the following: the limit as x goes to infinity. Now we're factoring out x squared like this. And now if we do this, the first term becomes a 2. This guy becomes what? 3 over x squared. And you don't have to do it this way. There's more than one correct way to go about this. You might have seen you might be more familiar with something that goes like this: 1 over x squared. And so you multiply by 1 and you distribute it. Eventually you'll get to the same thing that I'm getting to. Just you have to find something that works for you that you resonate with. I just resonate more with like factoring. On the bottom, if I factor out x squared, there's a 3. If we say 14x divided by x squared, we're going to be left with 14 over x. And that last one is going to be negative 5 over x squared. Okay. So then this is gone because something divided by itself is a 1. Right. And so again, this is the same as if we had decided to multiply by 1 in the form of 1 over x squared over 1 over x squared. Right. And then we would distribute that like that times that, like that, like that, like that, and like that. And we'll essentially get to the same result. Right. So either you could do it in orange. I just prefer the blue. But they essentially have the same outcome. So now when we take the limit as x goes, once we get it in this form, and we take the limit as x goes to infinity, right? A fixed number over a really large number, this guy tends to 0, this guy tends to 0, and this guy tends to 0. Okay. And so then ultimately we finish with y equals 2 over 3. Okay. So what we're saying is that as x goes off to now, and we can do a similar argument for as x goes to negative infinity, right? We should get a similar result, the same thing. So we're saying as x goes off either to the far right or the far left, our graph gets really close to this y equals 2/3, right? So this is our horizontal asymptote is y equals 2/3, and our vertical asymptotes were. Where'd it go? Did I have to skip them? Yeah, there it is. X equals -5 and x equals 1/3. Okay. All right. And so with that, we're going to end the session here. And so from one beautiful mind to another. All right. Take care. Peace.